This is a video on section 1.7 related to continuity, and we're going to look specifically at problem 1.7, number 24. These are typically the most challenging problems from this continuity section. So here's the problem statement over here. We've been given some piecewise defined function, and there is a value of k that we need to find the value of to make this function h continuous. Okay, so we are in this problem given the function h of x. It's a piecewise function. There's a constant k, and this function is kx. The function h is kx when x is between 0 and 1, and the function is x plus 3 when x is between 1 and 5. Okay, so let's take a look just for example before we even start talking about continuity, before even discussing the continuity problem. You need to think about the function h of x, and what I mean by think about is, do we even understand what we are seeing? So for example, typically when you're given a function you can find some values of it. So let's say that x is equal to 1. What is the value of this function h of 1? Well, this function is defined in two pieces. It's k times x when x is between 0 and 1, 0 inclusive, not including 1. So the function value at 1 is going to be using this part of the function. So right here when x is equal to 1. So the function will be 1 plus 3. Okay? So that would be 4. What about when the function is 0.5 or 1/2? Okay? The function evaluated at 1/2. Okay? 1/2 is in this time, this interval. So it is going to be whatever k is times 1/2. So that would be k divided by 2. Where k, we still don't know, it's an unknown value. It's just some constant. Okay, so it's k over 2. So that's this function. Okay, if you want to turn this into a sketch of this function, okay, something is going on from excuse me, x is equal to 0 0 to 1, and then from 1 to 5. From 0 to 1, when x is equal to 0, we get 0. So this function is going to look like a line. Okay? And notice that the limit as x goes to 1 from the left of this function, as you take values getting closer and closer to 1 from the left, so 0.99, you'll get 0.99k. So as x gets close to 1 from the left, it looks like our limit value is going to be k. So this function appears to be getting close to k from the left. And we decided that the function evaluated at 1 was 4. Okay, so the function was 4. We don't know what k is. We know the function value is 4. And it is a line that slopes up at a slope of 1 and would have a y-intercept of 3. So we'll just say that's about like this. So both of these are lines. Okay. This function, the x plus 3, is not defined over here for in the 0 to 1 range. So I'm just trying to draw a sketch of a line here. Okay. So that's using the table of values. We've got a pretty good idea of what this function is doing now. Okay. And the question is, what value of k do we need to make this function continuous? So let's do a quick recall. A function h of x is continuous at, say, x is equal to 1. 1 is our a value. If three things happen, the limit as x goes to a, in this case a is 1, of this function f of x, h of x exists. Okay. 2, the function is defined at a, the function value exists. Okay. And 3, that this limit that you find, that the limit equals the function value. Okay. So let's go through here and check this. We're trying to figure out what value of k makes this function continuous at 1. Clearly this function is continuous everywhere except at 1. So we need to figure out a way to make this continuous at 1. So h of 1 we decided did exist, and it was a function value of 4. h of 1 did exist. Okay. And as we currently have it, the limit does not exist, right? Okay. So this limit does not exist because the limit from the left, so we need to figure out a way to make this limit exist. The limit as x goes to a from the left of h of x. In this case, we're looking at the limit as x goes to 1 from the left of h of x. We decided that that was equal to k. The limit value from the right, we need, for this limit to exist, we need to figure out a way for the limit from the left and the limit from the right to be equal to each other. Okay. So according to this graph, the limit as x goes to 1 from the right, taking values close to 1 from the right, appears to be getting close to 4. Okay. So how can these two limits equal to each other? How can k equal to 4? Well, it just solved itself for you. Right here, k has to equal 4. Okay. So the function that is continuous on the interval 0 to 5, the function that is continuous on the interval 0 to 5 is the function 4x when x is between 0 and 1, and x plus 3 when x is between 1 and 5. Okay. So let's take a look over here now, just in case there's some people that are trying to use, move beyond their calculators and trying to use Mathematica. This is, remember from the website, there is a download for Mathematica through the university. And if you want to put in a piecewise defined function, you go to Writing Assistant, and that will bring up this thing. And right here is your piecewise defined function. Let's give this function a name, h of x. A little bit of syntax involved here. This would be k times x, and this is when x is 0, less than or equal to x, less than 1. Tab to go to the next value, it's x plus 3. 1 less than or equal to x, less than or equal to 5. Okay. Shift return will define this function for you. And notice that if we go before here, hit enter, and define k to be 3, let's let k equal 3. Hit shift return, notice that it fills in the value of 3 for k. Hit return after this, and you can say plot this function, h of x, from x going from 0 to 5. Okay. And when you plot this function, notice that it is not continuous. This particular, when k is equal to 3, our 3x is a line which comes up. The other function x plus 3 was here. They don't meet in the middle, so this function is not continuous. So if you start changing k values at random, 3.5, hit shift return to replot this function, still not continuous. How about 6? You know, if you hadn't done the steps over here, you're just kind of guessing in the wind, right? But we do know that because of the steps we've done over here on paper, we know that when k is equal to 4, the function is continuous. Here's the 4x, here is x plus 3, and this function does meet. The limit from the left and the limit from the right are 4. The function is defined and it's 4, and the limit from the left, the limit and the function value are the same. So if you look at this plot and look at these properties of a continuous function, you will see that this function satisfies each of those properties. So you have many practice problems of this nature to be given a piecewise defined function and to find the value of k that makes it continuous. And usually the difficulty is to figure out at the point where it jumps right here. You notice there's a switch in this function at x is equal to 1. So most of the time you'll have to pay special attention to this point where the functions switch. In this case, at x is equal to 1, the function switch from kx to x plus 3. So that should be a good example to get you started on continuity. Here's the definition of what it means to be a continuous function, and you can move on from there.